Good morning, everyone. The title on the schedule is a bit wrong of my session because it just says Java EE in the cloud. Well, I'm going to talk about that, but I'm going to talk a lot more about modularity and Java EE. That's the most important aspect of this talk. And we're going to see why this is important if you go to the cloud. So that's what we're going to talk about. Let me first introduce myself. My name is Paul, and I'm from the Netherlands. I'm working for a company called Luminous. And well, I do all kinds of stuff there. Basically, I'm just programming the whole day and doing technology, which is mostly new stuff. So I'm not working for customers most of the time. I used to do that a lot, but not anymore. And I'm just developing our own products and our own stack, more or less. Before that, I was a trainer for a few years, and I gave a lot of training in Java EE and other Java-related technologies. So that's what I do. And I work quite a lot on different open source projects. For JBoss, I worked a lot on Forge, for example. Currently, I'm working a lot on Apache Ace. So in different communities, I do some open source work. OK, let's get started. There's a trend going on, and this trend is not new. This is a trend which is already going on for many years, you could say. But what you can see if you look at applications is that they get bigger and more complex, which is not that strange because, well, we get better at creating software, and users start to expect more and more. But stuff gets more complicated. At the same time, we start to apply practices like agile development. And we want to change our software more often and more quickly, which is a good thing. It's all good, because we have learned from the past that waterfall methods and stuff like that just don't work. But we have to be able to change software often, and we have to do that in a complicated system. So we have a complicated system, and we have to make changes to that all the time. OK, so that's just a problem which we have. And the other problem, well, not a problem, the other thing that we are doing is bringing stuff to the cloud. And I'm going to talk about it a lot more later. But if you have complicated software and you have to make changes to that often, we have some challenges. And these are also not new things. These are just things that we have dealt with for many years already. But we have to, well, make sure that it keeps on working. And we have to make sure that even if we do maintenance on a complicated piece of software for many years, that we can still figure out how to do that and not just end up with a big bunch of spaghetti code and nobody understands what it's doing anymore. So we have to find a way to have our large, complicated piece of software and keep it understandable for other developers and for ourselves. And then there's the cloud. This is the thing that we have started doing like maybe 2 years ago. And more and more people are starting to apply this right now. 2 years ago, mostly people were talking about it. We should move to the cloud, and the cloud would be so awesome. But now people are actually doing this. And we're facing new challenges with that. Well, the cloud can mean different things to different people. The cloud can mean, well, I'm not going to buy a server anymore, but I'm just going to rent a server somewhere. Well, that's not that interesting. Because it doesn't really matter if you buy your own server and deploy your own stack on it, or you just rent a server in the cloud and put your stuff in it. That's not really that interesting. What is interesting is if you start to apply well, practices that are more related to the cloud. For example, what if we start to build our own SaaS application? So we start to build our own software as a service software, and people are starting to use that, and we deploy that in the cloud. Well, then we have a lot more challenges. Because if you are building your SaaS application, you probably don't want your system to go down every time that you have to do some maintenance. Downtime for maintenance is OK if you have like 100 users and they all sleep at night at the same time. That's fine. But in a typical SaaS application, nobody is ever sleeping, because there's always someone using your application, because people are from all around the world and probably have a lot more users. So downtime for deployments is not really acceptable anymore. So you want 0 downtime deployments. And of course, we have some solutions for that, like a cluster setup, and you can start changing nodes one by one. But it's quite complicated. Something else that at least I would like to do, if I change a few lines of code to do a bug fix, for example, I just want to upload those few lines of code and deploy those instead of packaging up my whole application, many megabytes maybe, and upload that to some cloud server and hope it starts up again. Why would you have to deploy all your code if there's just a few lines of code changed? It doesn't really make sense to me, at least. And the other thing that at least we see in practice, because we're doing this stuff, you can deploy a SaaS application, but as soon as people start paying for that, they want their own extensions on it. And that means you have a few variations of your code for different customers. And this is always a problem, because how are we going to do that? Are we going to do branching in our version control and make sure that at the source code level we start to differ between different customers? Well, if you have ever done that, you know that's really painful. And it gives you a lot of overhead during development. Why could we not just say, well, we have some code for customer A and some code from customer B. They're completely separated. And we just deploy them together. And depending on the customer who is going to log in, they're going to get their own software. This is all trivial questions. This is nothing new I'm telling you. Well, at least I hope so. But it's not that easy to solve if you're just doing Java EE as we've been doing for the past 10 years or so. It's missing something. And what we think is that modularity is the answer to those questions. First of all, modularity gives you a way to build a large piece of software and still make sure that it's easy to understand. And this is all about the divide and conquer. So you slash up your software in many small pieces. All those small pieces, well, they are easy to understand because it's just small pieces. And all those pieces together, well, that's your software. And as we will see later on, this also solves the problems that I was just talking about when we go to the cloud. So we want to do modularity, but what exactly is modularity? And modularity is for certain nothing new. They've been talking about this, well, as soon as we've started doing software development. But even today, not many people are really applying it that much. But let's go back a step. Let's go back to the days of university, and let's start talking about object-oriented programming for a moment, because that's where it all starts. And what we have learned at university is that we have to prevent tight coupling, and that we have to promote cohesion. And if you look at the picture at the bottom right, you see those two boxes. Within those two boxes, you want to have, you can have tight coupling, because if you don't have any coupling, nothing is happening in your system. There have to be some coupling somewhere. But those two blocks, that can be modules, and those have to be cohesive. So they have to be good at one thing and be small enough to still be easy to understand, even if there's some coupling going on within those modules. This is just basic object-oriented programming, nothing new. The problem is, as soon as we start to move up to bigger pictures, so if we move up to an architectural overview, for example, we forget about this. And there's not really any way to talk about this on an architectural level. We apply this at the code level, but we don't apply this on a bigger scale. Well, we try to apply this on a very large scale in SOA, and we failed at that. And especially enterprise architects like to talk about that, and they want to have reusable systems at least. But we have these reusable systems, then we start talking about code, and there's nothing in between. But we have to talk about this stuff at a little bit a larger level than just classes, but smaller than whole systems. and that's all about modularity. So how do we prevent tight coupling in a code base? Well, nothing new again, I hope. We use interfaces. So instead of using implementation classes from one class to another class, we separate everything with interfaces. And of course, at some point you have to use implementation classes because otherwise your system is not doing anything. But your modules, at least, have to be separated by interfaces. And that's the way that you can do the divide and conquer trick, that you say, well, I have just a piece, a block of code, and that's one module, and the only thing that someone else is seeing from that are my interfaces. But then we have a problem, because how are we going to make sure that nobody is accidentally going to use implementation classes? And this is a real challenge, because in Java, we can't really do that. In Java, we have the access modifiers, public, private, protected, etc. But first of all, they are just at a class level, which is too fine-grained. And second of all, it just doesn't work, because you always need public at some point, because otherwise you can't really do anything. And there is just no way in Java that you can really prevent someone using implementation classes. And of course you can say, well, if someone is doing that, it's his own problem, because he chose to do that. But if someone else is working on a code base that he don't fully know, because the software is just too big, well, how does he know? How should he know which is an implementation class and which is an interface, for example? Well, people start using namespacing, so we create packages and call them implementation, or we call a class implementation. And these are all tricks to work around this problem, but there's not really a completely working way to do this, just tricks to work around it. What we should have is something like this. We start talking about modules. So we've done the divide and conquer trick. So we said, well, those few classes, they do some kind of functionality together. Those few classes, they can use each other implementation classes, because otherwise they can't do anything. But we package those classes together and call it a module. And within a module, we want to define which classes or which interfaces are public, so which classes should be available to other modules. And we also want to say which classes should be hidden. And again, in plain Java, this is currently not possible, but I'm going to show a way to do it anyway. So, for example, module A has a public class, class A and class B, and other modules are allowed to use those. The implementation classes at the bottom should be invisible. They should just not be there. Same for module B. Module B only has a public class. Probably there's an API module with just APIs in it. And module C doesn't even have any visible classes. They're just implementation classes. And how that would work, you will see in a moment. And within the module, we want to define very clearly what packages are exported. So which packages are visible to the rest of the world. And everything which is not exported is just not there, if you look from it from the outside. And at the same time, if you want to use classes from another module, we have to define our imports. So we have to explicitly say, well, I can only work if those other classes from those other modules are available. So that if you deploy it, you can actually get an overview of if all the modules are there or you're still missing something. Okay, but then we still have a problem, because if we start saying that we don't want any implementation classes, and we just want to work with interfaces, and only those public interfaces, that are the classes which are public, which are exported in a module, how are we ever going to instantiate a class? How are we going to actually do something in our code? Because we can't do new my implementation, because my implementation is hidden, and I just can't do that. The compiler will not allow me if my module system is working correctly. And this is where service lookups or dependency injection is coming into play. I'm going to talk a little bit about OSGi in a moment. And in OSGi we talk about services. I will explain that more. And in Java EE we have CDI, of course. And CDI is more or less the same thing with a different name. There we call it dependency injection, but the idea is the same. So our modules, in this case module A, can actually register a service, which is just an implementation of an interface. They can register it to the container, to my service registry, or in CDI to the bean container. And say, well, I'm an implementation of this interface, and other code can start to use me. Module B just has a dependency on the interface of my implementation. Only the interface, not the implementation. And as a request to service registry, please give me some implementation of this interface. And of course, this is exactly what you're doing when using CDI in Java EE. And the service registry will give the instance created by module A, and will give it to module B, and it will start working again. And there's no place where we start to use the new keyword. And this way we can have our private classes, our private implementation classes, because module A can register itself in the service registry, so it doesn't have to be public. And still other people can start using us strictly by interfaces. So go back to this picture for a moment. We have module C here. Module C only have private classes. Those will probably be registered to the service registry, so other people can start using them. Maybe implementing class C from module B, which is it might be an interface, and that way we can still use this code. So if we start to apply modularity, there are basically two parts of that. And it starts with the most important thing, which is design time modularity. And this is all about architecture and all about divide and conquer. Instead of having a huge code base in just one project and just keep on adding classes and interfaces to that project, we want to have small projects with just some code that belongs together and keep everything small. And all those projects together, all those modules together, well, that's your system. And that system might be complicated. But on a code level, you just talk about a few classes together. And a few classes together is just easy to understand, and maintenance will be a lot easier than when you have just thousands of classes in your project without understanding what belongs to what. And well, this is all about separation of concerns. This is not something new. This is what architects talk about all day. That's why they draw those pretty blocks on whiteboards. And the only problem is that it's difficult to implement it. And to implement it, we should have a module system. If you start deploying this stuff, we see that in Java, a jar file, well, that's basically our deployment artifact type. So we package up our code, we put it in a jar file, and that's what we're going to deploy. And if we have a project for each module in our project, in our system, then we can end up with a jar file for each module that we have. Well, great. If we start deploying this stuff, we end up with a whole pile of code that is just thrown all together again. And that's where modularity in Java is just broken. Because everyone knows about class path hell. Everyone have dealt with it. That's because in Java you can even you can deploy many small jar files which are maybe very modular, but on your application server you end up with just a big bunch of code where everything is put together. And if you have class loading issues in there, maybe two classes two implementations of the same class in different jar files, well, it's just by coincidence which one the application server will load. So this just doesn't work. And then we want a lot more because we want runtime dynamics. And this is important for the requirements that I talked about when I was talking about the cloud. We want module versioning. So we want to say, well, maybe I want to deploy 2 versions of a module at the same time. So some code can talk to my old module because they didn't upgrade yet, and some other code can start using my new APIs. Because otherwise it's always hard to change code. And when I want to do deployments, I just want to upload single modules instead of uploading my whole system every time I change a few lines of code. Another thing that I want to do is when I update a single module, I don't want the whole system to go down. I want to update it while the system is still running. Maybe hot switching to another module for a moment until the new module is available, and then we hot switch it to the new module. And this is just not there in standard Java or Java EE. So we need something else for that. So what do we need? Well, we have to start at the architectural level. And this is something everyone can do. Even if you don't have a runtime modularity system, if you're doing Java EE, you have to start thinking in modules at least. Maybe you can't deploy them as modules, but you have to start thinking in modules, because that's the way to keep your code base understandable. So instead of just having a large code base, we want to have many small modules at our code level, and that will at least help the maintenance. Besides that, if you also want to have runtime dynamics to just do everything like we want to do, then we need some kind of runtime which understands modularity. And at this moment, OSGi is probably the only option to use for real. There are a few other things coming. First of all, we have Jigsaw, which is coming in Java 8. And Jigsaw is more or less something that looks like OSGi. Not quite, but it at least solves the same problems more or less. And it's built into the Java language, which is good. The problem is that they are still missing some very important things. For example, there's no service layer in Jigsaw at this moment. So it will probably take at least until Java 9 until they get this thing right enough to start using for our modularity problems. And Java 9 is a long time away from us, at least 5 years. So if you want to do this today, it's just not an option. Well, we are at the JBoss conference, so I should talk about JBoss modules. The JBoss application server is built on JBoss modules, which is also similar to OSGi, simpler and faster. That's why they choose it for the application server. And it works because the application server is using it. At this moment, I would not recommend it for application development, simply because there's hardly any documentation. There are not many people who know about it, so there's no community around it. And there are still, to my opinion, a few things missing on the, especially the runtime modularity, which are just not there. They choose to not put it there because it's faster that way, which is important for the application server. With application development, you do need those things. So, to my opinion, at this moment, OSGi is the only way to go for modularity. At the same time, we want to keep using Java EE, of course, because Java EE has all kinds of nice APIs to do things like transactions and work on the web, do RESTful web services, etc., etc. And we don't just want to throw that away and start doing everything ourselves again. And a lot of people think that if you start doing OSGi, you have to do everything yourself because you can't use Java EE. Well, this is partly true, and at least it was true in the past, but things are changing very fast at this moment. So what we're going to do is combine OSGi together with Java EE to get the high-level APIs of Java EE, and at the same time get the modularity provided by OSGi. One thing I should say is that if you start using OSGi, you will not automatically get modularity. Modularity is something that starts at the design level, at the architectural level. And just starting to use an OSGi framework will not automatically give you a modularity solution. You've got a modular runtime, but you still have to do all the right things yourself to actually get the benefits from it. When people hear about OSGi, they are most of the time just complaining that it's too difficult, it's hard to use, it's a pain in the ass if you want to do just development, because there's a lot of things that you have to do. The first thing that you have to do in OSGi is define your modules and define your exports and your imports that I talked about earlier. You have to define which packages are public and which packages are private. And this used to be just not nice to work with. By the way, if you look if I look at myself, I've been doing Java EE like forever, since I started doing programming. And I was not using OSGi until like a year ago. And I switched companies, and I started working with some guys who are, the guys in the OSGi world. So they're working on Apache Felix, for example. They wrote books about OSGi, so they know what they are talking about. And that's the way I got into OSGi. So I have a very strong Java EE background, and then started to think about modularity, and thought, well, this is actually very useful, and we have to do both. So I'm not here just to promote OSGi and say, well, you shouldn't think about Java EE or something like that. Absolutely not. I think we should do both. I just want to give you a very short demo to just show, with the current tools available, how easy it is to work with OSGi and how easy it is to create bundles. So let's switch to Eclipse for a second. I'm not going to do any live coding today. No. So what I'm using here is Eclipse, and within Eclipse I installed a plugin called B&D Tools. And B&D Tools is probably the best way at this moment to do OSGi development. Because it gives you a lot of nice things, like some wizards to define your bundles, and it gives you a way to run an OSGi framework, and code changes will automatically be deployed, you could say, so you get a very fast development cycle. So we're not using Maven here, but we're using B&D Tools instead to build and define everything. So let's start with a simple bundle. What I have here is just a simple Java project. And this agenda.api project is just my APIs. So there's no implementation classes here. These are just my APIs, and this is best practice if you want to do modularity. You put all your APIs in separate packages, in separate modules, instead of putting them together with the implementation classes. So I have two interfaces here. And those two interfaces, well, they should be packaged into a jar file. And besides that, I want my exports to be generated for me. So what we have to end up with is a jar file. And in that jar file, we have a meta-inf folder. That's the place in OSGi where you define your modules. And within that, I've got my manifest.mf. And I will make that a little bit bigger. So there are pretty much two interesting things here, which is the export package. And this export package says, well, I'm exporting the agenda.api package with a very specific version. And this version, which is important, because it says, and it will automatically be calculated, if I do major code changes, so if I change remove a method from an interface, for example, it will be a major change, a breaking change. And I have to upgrade my major version. So that if I deploy that bundle, then other bundles which were using the old version of the interface will see, well, those are not compatible anymore. So I have to either deploy the old version of the bundle or change my implementation classes. If I just add a method to an interface, it's a minor change because only the implementing classes will break, not the consuming bundles. And if I just did some code changes without breaking any interface, it's just a micro change. And this is called semantic versioning in OSGi, and this is very important if you have a large system and you can't just change all the code at once. So the question is, how do I write those export packages? And I'm certainly not going to write them by hand. and it's not supposed to be written by hand. Instead, I've a wizard for that in BND Tools, and I can just drag a package, put it in the export packages or the private packages, depending on what I want, and it will automatically generate the jar file and the manifest file. So that's pretty easy. The other thing is, what if I have an implementation of this interface? So for example, I have my simple agenda service, and the simple agenda service implements my agenda service. So I need this on my class path, first of all, because that was in my API package. And besides that, it's just plain Java code. Nothing special about this. So let's first look at how this bundle looks like. I go to the BND file again. And if you look at my private packages, I said, well, in this package that I just showed, I have some private classes. So they should be packaged in a jar file, but not be visible to other modules. And on my build path, I specify I need the agenda.api package. And if I do that, I just get a whole list of all available bundles that I have in my repository. A repository is similar to a Maven repository. You just put jar files there. And I can just put things on my build path, and then Eclipse will start compiling against it. And if you look at the generators file, the meta.in file again. And what we have here is an import package, and this import package specifies that I need the agenda.api package, which I exported in my API bundle. I didn't write this at all. It will automatically be calculated by the IDE. So as soon as I start compiling against the class, it will recognize, well, I need an import for that, because otherwise it will not be available runtime. And it's easy as that. So if you're used to doing Eclipse, not much chances. Most of the stuff that's happening happens automatically. So you don't have the pain of creating manifests yourself and putting stuff in the right place in bundles, etc. It will all be done for you. The other important thing is registering services. Because I said, well, if you have an implementation class, you have to register it as a service so that other classes can start using it. This simple agenda service is an implementation of the agenda service, and I want to register this to the service registry so that someone else can start using it. And in this case, I used an activator for that. An activator is a class that you can define in your bundle, which will automatically be called when the bundle is started in the framework. And there are many ways to do this. You can do this very low level directly on the OSGi APIs, and there's a service registry class or interface, and you can start registering your services to there. But if you start using this low-level API, you have to deal with all the low-level stuff like thread safety, and which is complicated. So if you start doing OSGi, don't use this low-level APIs. Use a dependency injection framework instead. There are many dependency injection frameworks for OSGi. They all do more or less the same. Even a few different standards to do so. And in this case, I use the Felix Dependency Manager, which has a Java API to say, well, I register an agenda service, and my implementation is the simple agenda service. That's it. You can do this by annotations if you prefer. There are annotation processors for that. And there's a spec currently being written to do this with CDI. And that will be much more interesting even, because then you can use your Java EE dependency injection framework to work with OSGi. It's not finished yet, but it's currently available as a prototype. If you look at the other way, the consumer of my service, I just defined that I'm using the agenda service all in the interface, not the implementation class. The implementation class is not even visible for me. And once again, I used, in this case, the Felix Dependency Manager to say, well, my console implementation has a service dependency on agenda service. And the service registry, the framework, has to figure out who delivers this implementation. This is just basic dependency injection, nothing special about that. The other nice thing is that I can just start this. So I can just start my application. It will start an OSGi framework right here. If I make code changes, it will immediately be available in my running application. So I never have to do a restart of my framework or a restart of all my code. It just restarts one bundle. And in this case, I also have an OSGi console installed. You can see there's a whole list of bundles right here. And which is interesting, one thing that is interesting is that we also get the runtime dynamics now. So I have another service here, which is a JUDCon service. This JUDCon service uses the agenda service again. You don't really have to look at the code. And it just gives back some JSON. So this is my agenda service. If you look at this JSON, and we're going to look at the bundles, we will see there are two implementations of this agenda service. I just deployed two different implementations. One with an in-memory list of conferences, which we see right here, and one running on a Mongo database. So I go back to the simple service for a moment. You see, those are the conferences here. In Mongo, there are some other conferences. And I can just go here, try to find my simple service. It's bundle 25, and I can stop bundle 25. So bundle 25 is not available anymore. If I reload this page, you see it automatically switched to my other implementation, to my Mongo implementation, because it was there, and it will just, well, hot switch to that implementation. I didn't have any downtime here. So this is interesting if you go to the cloud to start to do your SaaS application, for example. But we didn't only want to use OSGi. And in the past, it's always been, well, more or less a shootout between OSGi and Java EE, because the OSGi guys always said, well, Java EE sucks and it's heavyweight and not modular, etc., etc. And the Java EE guy said, well, if you start doing OSGi, well, great, you have modules, but you can't really build an application with it because you don't have transaction management and you don't have a web framework, etc., etc. So neither one of those is actually the right way to do enterprise development. And luckily, times are changing. At one side, we're going to start using OSGi for our low-level modularity. That's where OSGi is good at. At the same time, we're going to use Java EE to use the high-level APIs from Java EE. And we're just going to let them live together. And at this moment, there are three different options to do so. And the first option is the most interesting one, and I hope at least, and I think that's where it's going. I hope this is going to be the way we will do enterprise development in a few years. We start using OSGi as our core programming model. So everything we do is a bundle instead of just writing code and put it at a random place. So everything is a bundle. But from those code, we're just going to do use Java EE APIs like we would do now in a normal Java EE application. So if you just look at the code, it just all looks like plain Java EE, nothing special about it. We're going to use CDI, for example, for dependency injection and service registration. And we're going to use EGBs as transaction management and stuff like that. But everything is packaged in a bundle. I'm going to give some examples of that, because it's already possible to do so. The second way is to say, well, I've got a hybrid solution. And a hybrid solution is, well, I've got some code that I want to make very modular. And that's where I'm going to use OSGi. And I have some other code where transaction management and stuff like that is important, and that's where we're going to use Java EE. I'm also going to give an example of that. And of course, you can do what OSGi guys have been doing all along, is just use OSGi and start with an empty OSGi framework and start putting bundles in there. Which is going to be also interesting because you see that a lot of the frameworks used in Java EE, like for example JUDCon, are also available directly as OSGi bundles. So you can more or less build your own stack with a lot of Java EE APIs available and still using a plain OSGi framework. Let's start with the first one. So what we're going to do is just write everything as a bundle. But within those bundles, we're going to use Java EE. And we're going to deploy everything in an application server, like you would do normally in a just normal Java EE application. So we're not just going to use an OSGi framework, but we're going to use an OSGi framework within an application server. And this is starting to get possible. If you look at the different application servers available right now, most of them, well, actually all of them, they support some way of deploying OSGi bundles. And if you look at some application servers, well, actually also all application servers, all of them are built in a modular way. If you look at a Glassfish server, for example, it's built in OSGi. If you start up Glassfish, you're just starting up a Felix framework, the OSGi framework, with a lot of extra bundles installed in it. That's what you start up. So it's just OSGi. If you're using the JBoss application server, it's built in JBoss modules with OSGi on top of that. So it also supports OSGi right there. So if you want to start to use the Java EE APIs, there are starting to be some standards in both in the OSGi space and in Java EE space to let them coexist. So for example, we have the web application bundle specification. And a web application bundle is basically just a WAR file, like you normally use for Java EE, with a manifest in it. And that's the only difference. Your application server will pick those WAP files up like a normal WAR file, so your servlets and your JUDCon resources will just be registered by using annotations like you would do in Java EE. But at the same time, you can define your imports and your exports in your manifest, so it's still all modular. And this is available in most application servers right now. It just looks like this. I have some code, like in this case, the JUDCon resource. I have my manifest, and the only special thing about this manifest is that it has a web context path. And this tells the application server, well, it has to listen on a certain context path. So in this case, the example, the agenda example, will listen on my web, because that's my context path, agenda. And writing that manifest is the only extra thing that I have to do to start using OSGi instead of just using plain WAR files. And of course, I can have many WAR files, many WAP files, all with maybe one resource in it, so they're all separated modules. Another interesting thing, and this is only available in Glassfish at the moment, they're more or less prototyping this, and at this moment Glassfish is the only one that has this, is using transaction management together with JPA and EGBs within an OSGi bundle. And this is also very interesting, because what we can do is just write our EGB with using a persistent context in this case for using JPA, and package that in a bundle, write our manifest again, and export those EGBs as OSGi services. So I can have other bundles, which can be just plain OSGi bundles, and use those EGBs as they would just be OSGi services. This is not working entirely correctly yet. In Glassfish, this is full of deadlocks at this moment, so if you deploy this, it will probably fail. But they're at least working on it, and it's, at least interesting to see. If you look at the roadmap of the OSGi implementation on top of JBoss application server, they're also working on this. In a slightly different way. It's a slightly different way to use transactions and a persistence context in your OSGi code, but with pretty much the same features. It's not there yet, but they're working on it. Another very interesting thing is that in the OSGi space, a spec is being written at this moment. Well, they started writing it to use CDI from within OSGi bundles and to use CDI to export and import services. So the things that I did with an activator and Felix dependency manager just now in the code can be done with CDI. This is being prototyped in Weld, the CDI implementation, also made by JBoss. And so you can start playing with it, but the specification is still under development. If you look at the current, the possibilities of the application servers out there, you see, well, at least a lot of work is being put into there. And depending on your requirements today, well, that can mean that you can actually start using this today, or maybe you have to wait for a little while until we get better application server support. Green mark means that it's available, so you can start using it. And you can see, unless you're using WebLogic, which doesn't do anything, you're good to go if you want to use just the web functionality, so the WAP files. And on the EGB, JPA transaction side of things, well, it's a bit more complicated, and at least they're trying. You see different ways of dealing with this, and probably there will be a standard at some point, but it's not there yet. So you just have to see what your application server is offering today. So the other thing you can do, and I'm not a big fan of this, but a lot of people are doing this, is just say, well, I've got some code which should be modular, where I want to have runtime dynamics, and I have some other code that's just Java EE. And I'm not going to combine them. I'm just going to deploy both of them, and I'm going to build a bridge between them to interact with each other. So basically, you have two different containers. And you can do this using JBoss AS, for example, and people are doing this today. So this is an example. This code example is simplified. It's not thread safe, so don't copy-paste that, please. But the code at the top is just an OSGi service. I use annotations here to define my OSGi service. This is just a servlet using Java EE, and I just inject a bundle context here, which is the low-level API of OSGi to work with the service registry, and I just look up that code. The bad thing is that this code can't be deployed in a modular way. So this is just deployed in a standard var or ER file, which is why I don't really like it. But if you have the requirements for this, this might be a good way to start working with this until we get better application server support. And of course, you can also say, I'm just going to start from scratch. We're going to use an OSGi framework, build our bundles. We're not going to use an application server, just the OSGi framework. And we're going to, well, maybe use some Java EE APIs, but we're going to package them up and put them in our OSGi framework ourselves. You need a lot more in-depth knowledge for this, and it can be a lot more work, but given the right kind of application, for example, if you don't do transaction management, so you don't need EGBs anyway, and you don't use JSF, for example, well, this might be the best way to do so. Actually, at the moment, for the application that I'm working on right now, this is what I'm using. Just plain OSGi and use some Java EE APIs, which I package myself. Not ideal, and I hope we will not use this for a very long time, because I hope we will go to option 1, that we can really, truly have hybrid bundles. I'm going to skip the demo, by the way, because that was actually for a much longer talk. So then the last topic, which is deployment, because how are we going to deploy those bundles? If you start to do modular development, we end up with a whole bunch of small bundles. And how are we going to deploy this? Should we say, well, I'm going to package up all my small bundles within a large zip file or a var file or an ER file or something like that, and deploy everything completely? Well, that doesn't make any sense, because we did so much hard work to make everything small and modular, and then we're just going to package up everything again and forget about modularity. And it's even more important if you're working in the cloud, because the server that you're using is not standing next to you on a high-speed network connection, but it's connected to the internet. So if you upload your stuff, it will actually take a while, because probably your upload speed is limited. So why package up a 50 megabyte var file if you just changed a single line of code? Instead, you want to deploy separate modules. And the way to do that is using Apache Ace. That's also something I'm working on myself. And it basically works like this. You have your development machine or your build server or, well, some machine that, where you build your bundle files. You're going to upload them to Ace one by one. You don't have to package them. You just upload those modules directly. And then you have a whole bunch of servers. And those servers are all running a management agent, which is just one OSGi bundle, which connects back to the Ace server and say, well, hi, here I am. And we start using Ace to say, well, I'm going to get a few of those jar files together, call it the distribution, and start uploading them to one or more servers. And if I update a single bundle, I just upload that single bundle again to Apache Ace, and it will automatically provision it to all my servers. So I don't have to go to all my servers and update the application myself. Now I can just let Ace do that for me. So this is how it looks like. On the left, we have all our artifacts. So these are my bundles, very fine-grained. I can group them as a feature. Features can be grouped in a distribution. And at the right-hand side, we have our targets, which are our servers or devices. And as I said, the only thing you need there is just a single OSGi bundle, which is the management agent. You can even install them in your application server, like JUDCon, which supports that. And as soon as I hit the store button at the top, it will actually provision all my bundles to my server, and it will start running those. If I update one of those bundles, only that one bundle will be provisioned to the servers. It will not do a full redeployment. So it's a lot faster, and it takes less than a second to update bundles most of the time. So this is how we do, how I do production deployments at the moment. I've got like 20 servers, and all those 20 servers have to be updated as soon as I start changing code. And I just update one of the bundles, upload them, I hit the store button, and a second later, all my 20 servers are updated again. And they're not running in a cluster or anything, it's just single servers. I can start using this for cloud deployments because I can just start cloud nodes here. This is all built on JClouds. And I can, for example, use the Amazon cloud, start defining my server type, how big the server should be, etc., and start running it from there. So, what have you seen? We've seen a few things. I hope at least, that you've seen the future of enterprise application development. I hope that it will get easier and easier, and you see that right now in the application server space. It gets easier and easier to do modular development in the Java EE world, and I hope that's where it's going, and I hope in a few years everybody is doing this, because it just makes everything so much easier to maintain and to deploy. I've shown some different possibilities to do it right now. Option one is use your application server support and just build hybrid bundles while using OSGi APIs. We've seen the solution that you use an OSGi framework next to a Java EE framework. That's possible today. And we've seen that you can just do it plainly by using an OSGi framework. I've done this talk a few weeks back for the JUDCon. It was recorded. It was a 2-hour session, and I've got a whole lot of demos there. So I will actually show you how to build this stuff from code. That will be published on Parlays in a few weeks. I don't know exactly when, but that will be announced. And if you are interested in seeing more code related to this, you should check out that talk. It's basically the same talk, but with a lot more time. And then you can see a lot more code also. If you want to know more about this, the book on the left is really recommended. It's about Java application architecture and how to do modularity. That book is not about OSGi. It has some OSGi examples in it, but it also tells you how to do modularity without OSGi. So even if you can't do OSGi today because your application server doesn't support it, for example, it's still very interesting to read because it's really about architecture, and that's where it all starts. If you do want to know a lot more about OSGi, you should check out the book on the right. It's written by a colleague of mine, Carl Pauls, and that just tells you everything about OSGi. A few references. Apache Ace is the deployment tool that I showed you a moment ago. We do a lot of work on that from Luminous. Amdatu is an open source initiative, also by Luminous. We built some cloud-related OSGi bundles there. So, for example, if you want to use a Mongo database, you can easily do that using OSGi services. If you want to do JAX-RS in an OSGi container, that's what you can do. Well, it's all open source, so you can start using that. BND Tools is the Eclipse plugin that I used, also open source. And Luminous, that's where I work for, and that's us. Thanks a lot for listening to me. And later this day, in the afternoon, I have another talk about migrating Spring to Java EE, so come check that out too. And thanks a lot for your attention.